Welcome to the Real Python Podcast. Are you interested in building REST APIs with Flask and SQLAlchemy? This week I interviewed Doug Farrell about his 4-part Real Python series on Python REST APIs. We discuss the various Python tools and libraries used in the series, and Doug also shares his practices for continuous learning. Doug has worked in process control, embedded systems, and has a long background in software development. He's currently a developer at ShutterFly, and he discusses developing tools for his internal customers. Currently, Doug is writing a book for Manning Publications, The Well-Grounded Python Developer. The book is currently available in an early access state. And as always, don't forget to check out the show notes with links to all the different topics and tools that we discuss throughout the episode. So let's get started. My name is Christopher Bailey, your host. The Real Python Podcast is a weekly conversation about using Python in the real world, interviews with experts in the community, and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, Doug, welcome to the podcast.
Thank you very much, Chris. I'm glad to be here.
Why don't you give us a little bit of your programming background?
Sure. I'm an older developer. I got started back in the 80s, actually, by buying my first personal computer, a Radio Shack color computer, which I got hooked on and taught myself BASIC back then and a little bit of assembly language because the color computer had a clock speed of less than a megahertz. It was a kilohertz clock.
All right.
So to really do anything, you had to do some assembler. Then I did some work. My degree is in physics. I have a BS in physics. But my senior project was building a very primitive CAT scanner with a Pascal-driven computer.
Oh, wow.
With the department head. That was a lot of fun and interesting. And it sort of gave me enough buzzwords to get my first job.
Okay.
As a process control engineer doing, gas pipeline and municipal water system control systems, big, large distributed control systems for clean water and gas distribution.
All right.
And they had their own proprietary language doing control stuff. But in a few years, I jumped over to the software development group and did Fortran and then C on the old Digital VAX VMS systems. And I never looked back. I mean, I've been a self-taught programmer ever since. I learned after that job, I dove deep into C++, doing embedded systems for a machine control company, doing kind of a high-speed robot thing.
What was the robot doing? What was its job?
Well, it's called a pick-and-place machine. Essentially, it assembles circuit boards. So it has a big line of parts, little resistors and capacitors and multi-leg circuits, chips, and it picks up parts with a little vacuum tip, flies them over a camera. The camera takes a picture on an interrupt.
Okay. To
determine, how offset or how rotated the part is. And while it's continuing to fly over to where the board is, it's calculating the kind of correction it needs to do to orient the part. And then it slaps the part down on the board in precision. And we're talking thousandths of an inch precision to place these parts. And it's doing, I think the fastest one I worked on could theoretically place 20,000 parts an hour.
Wow.
So that's really flying.
Yeah, definitely.
And it was a lot of fun. It was a great deal of fun. In that kind of a world in embedded system programming, you're very focused on speed and getting the most performance out of the CPU as you can. We had at that time, it was a 486 processor, and we were writing in C++, C actually, and C++, and using a lot of function pointer tables and all this other wacky stuff to do this kind of a soft real-time system that it could do all these things, move the motors back and forth, move the parts around, take pictures at the same time that it's doing calculations and drive the user interface. So that was a lot of fun.
I think about those machines back then, the computers from that era, and the idea of having like a math coprocessor. Is that something that those machines would have?
That one did. When we moved, we moved off the 46 soon after that, and we moved to the Pentium, which had a coprocessor, and that was a huge advantage for us because although I did a lot of calculus getting my physics degree, I think the biggest math thing that I've used since was trigonometry, and that was part of this job. There's a great deal of trig involved in translating the parts and rotating the parts, get them in the right orientation for not only being on the tip that's placing them, but their orientation on the circuit board that you're putting them on. So there was a lot of floating point math in order to get the parts to move the way you wanted to.
Oh, cool.
Yeah, that was a lot of fun. It was I guess I did that for 4 years. I guess that was a lot of fun.
Do you still mess around with electronics in your own spare time, or is it's just mainly just your work stuff?
I do. I actually took one semester of electronic engineering, thinking I wanted to change my major from pre-engineering to electronic engineering. And unfortunately, the course I took was strictly focused on analog circuits. We were learning how to build power supplies and things like that, and I could care less. I just wasn't interested. I was very focused on digital electronics.
Yeah, you're in the digital world already.
Yeah. And so I didn't do very well in that course, and I stayed with where I was and got my physics degree. But I have done a little bit of electronics work after that. I've been very interested, lately after a lot of other stuff. Since I've gotten into Python, been very interested in MicroPython and trying to build control things using that. I built this. I built a Polargraph based on this GokuPy project. Essentially, it's a vertical XY plotter.
Oh, okay.
That uses 2 strings to move the pen around. And that was an interesting little project to put together. And I've been trying to modify it to do more stuff ever since and become more accurate. And then I also have this daydream about automating my house for Halloween.
Oh, my wife has basically petitioned, I don't know, maybe a couple weeks of my life for the next holiday season that I need to create some kind of intense holiday display.
Yeah.
And so I'm like, all right, well, at least it allows me to buy toys and play with them.
Right, yeah.
And try to learn this stuff.
There's all the projects around my house work that way. If it doesn't involve buying more tools, I'm not going to do it.
Is that for creating art in some ways, this plotting?
It is. It's not super accurate as an XY plotter, but one of the things I got into it for was this idea that in the last couple of years, I've gotten back into painting.
Okay.
I also have a 2-year degree in commercial art, a little bit of artistic talent, which I had not done much with in years. And I wanted to get back into it, sort of exercise the other side of my brain and to think creatively.
Yeah.
And so I got into painting. And one of the things I was thinking of was to use this Polargraph to draw on top of stuff I painted, to drew kind of like the shading, kind of a crosshatch shading on top of the painting using the Polargraph, and to see if I could get it to, with a camera, it runs on a Raspberry Pi, with a camera to take a picture of the painting and then be able to shade it itself based on what it sees, what it sees. And I was thinking this would be kind of a cool demonstration, like at art fairs, to show people while I was painting, to show this thing, running away.
Yeah, I think of that as like the inking. I mean, that's usually at a different layer in comic book art. I'm not big into comic books, but I know that, it starts out usually with pencils, and then there's various different styles of inking.
Right.
And so your designs that you created there, you could use different techniques for how you want to accent all your paintings. That's a cool project.
We'll see how far it gets. I mean, the motion control that came with it was very simplistic, and I'm trying to, sort of cash in on my embedded systems work to make it a little more sophisticated, and then do some image processing to, react to what it sees and see what happens.
Cool. At what point did you get into Python?
Well, I was, after a few more jobs, I controlled the embedded systems work. I worked for a friend of mine in a little startup doing, we were automating ancient, 50-year-old hydraulic machinery. We were turning into computer-driven machinery so they could do repeatability and quick setup. And that was a lot of fun. And then I got into an online reference title, kind of like the old, I don't know if anybody remembers Encarta.
Sure.
The old Microsoft encyclopedia. I worked for Grolier doing their online encyclopedia, and got into the web development from that point of view. And then part of that was converting from what they were doing. We got into PHP as the web development language, but the back end processing, there was a lot of, at that time, there was a ton of data. It was 80 megabytes of data. A CD was 700 megabytes. That was huge at that time. So moving a lot of that data and getting things around, a lot of the back end processing was done with scripting languages. They were sort of kind of heading towards Perl, which horrified me. The syntax of Perl, really, I didn't like it at all.
Yeah.
But the other thing I discovered, I was fortunate enough to discover Python, which really appealed to me because the clean syntax was one, but the object-oriented nature that was built into Python from the get-go. I was really firmly planted in object-oriented design from my C++ work at the embedded systems place.
That makes sense.
And so being able to do that in Python appealed to me a lot. I was there for a few years, and Python became sort of our go-to for that kind of the back-end processing work. And then I was fortunate enough that a company reached out to me. It was the predecessor to working for ShutterFly, who got acquired by ShutterFly. And they had an all Python shop, which was amazing. And I took the job there, and I've never looked back.
So what are the kinds of things you're doing at ShutterFly currently?
I work in the production department, and which means that we are actually producing the printed items that our customers upload. So I don't do any front end. I don't do any customer facing code. My customers are all production people on the production floor actually making things.
Okay.
So there's a lot of work to convert what our customers upload as images and PDF files. There's a lot of work to get that press ready. So there's a lot of Python work just to transform data and then get things into queues for various different kinds of presses, digital offset presses, and we have a lot of other various gadgets like laser presses and inkjet printing for canvas printing.
Yeah.
But to get all that stuff on the press, but after that, there's still a lot of work that we do to track orders. So as orders go through the system, they get scanned, like barcode scanning. Those events come into the system as real-time events into the database, which update the status of orders. All that stuff is tracked all the way from where something gets cut from the printer to bound to packaged to shipping and shipped. And all of that information is sort of, I would say, soft real time, but viewable by not only the people who are producing it, because they need to see what it is they can work on and where the work is, but by managers and line personnel to get a status of how things are going. Where are things backing up? Where do we need to apply more capacity to catch up? How much work is in flux? All of those things happen because of, a lot of those things, not all of them. A lot of those things happen because of Python code.
I can think of certain times of the year that's really going to shift dramatically for you guys too.
Oh, it's the fourth quarter is our big season with Christmas. And yeah, the workload is enormous. So we work very hard to make the systems scalable and robust because we really don't want to have to be online 24/7 in order to keep the thing running. So we try to create self-healing systems that are robust, can easily be scaled, recover from restarts pretty well. A lot of those things are really important to the way we work. I don't know if you ever I've thought about distributed computing where you have multiple nodes that are doing intelligent things.
Yeah.
It's kind of like that, but it's not quite a real time. I mean, it's not like a real time. Whenever I think of real time embedded systems, I always think of something fast. Like the machine I used to work on. Things are happening very quickly.
The one that was putting things in the electronics into the boards?
Yeah, exactly. That stuff is happening very fast. But in our place, it's more like those operations can take hours. When you get an order in, especially in the fourth quarter, if you get an order in place before it actually gets printed and packaged and shipped, that could be hours later.
Okay.
But I still have to track that thing. And those events happen in real time, but the lifetime of that process can be a long time.
Where does Python help you in that? What are the things inside of Python that make it?
Well, we have a couple of products that we cover. There's a lot of existing infrastructure that was done in Java.
Okay.
We're working alongside of that. Where I work is very heterogeneous tech stack. There's a lot of technologies there. But in our case, the products that we cover, and we're absorbing more and more products, it helps us by this partly is the speed of which we can develop tools.
Okay.
I think Python's plenty fast. It's very fast, I think. But the speed at which you can develop stuff is much more important than the actual computational speed, especially in our situation where things can take hours and hours to actually finish. So being able to take an idea or a concept of something that is necessary for the production line and turn that around very quickly in days or weeks rather than months is a real advantage.
And you're missing steps of like compiling.
Yeah, as everybody is, we're moving toward continuous integration, continuous deployment system, a way of doing things. So we're, as fast as things are getting tested and approved, they're getting out on the production floor. And, in an iterative process like that, well, we're trying to turn it become more iterative rather than, you get a list of like, I need this from our users, from my customers.
Right.
Somebody throws something over the wall and I need this, we throw it back. It's kind of an old style. We're trying to move to a more iterative process where they say, well, we need something like this. We're like, okay, here's something that fits that. And we go back and forth till we're refining that thing or that process to fit their needs. Because of the speed at which we can do that, that becomes really a useful tool.
Yeah.
What I've had happen plenty of times in the past is I deliver something, it takes a long time or whatever, and then I go out and I talk to the users or I meet the users maybe months later, and I find out that it's been broken for a long time.
Oh, gosh.
But they found a workaround, some horrible, terrible workaround that lets them to continue to use it.
Right, limp along.
But they've gotten used to that because for them, it's like, I need to get this done. I can't be bothered waiting for another month to get this fixed. So, but we're getting to the point where they're starting to trust that we can actually do that, turn that around quickly. So rather than suffer with some terrible system, we are getting the feedback we need to iteratively improve the system, which is fantastic.
Yeah, that's cool. You said you're primarily all self-taught, and
yeah,
I think about that. That's definitely my background. I've, find lots of resources out there. But what has been difficult about being self-taught?
Well, there's, I was fortunate enough when I first got started as a full-time developer, I worked with a lot of guys who were either, had CS degrees or had masters in CS. They had a lot of skills and knowledge that I did not. And so that helped me a lot initially to just think about things more like a developer and to pursue things that were very useful for them, like data structures and just a couple of techniques. I think the biggest thing for me is I'm very application driven. I'm not a computer scientist. I have something I need to solve. I have an application I'm trying to build, and that very much focuses my attention to the things I need to learn in order to make that application work. So that narrows down your
scope.
Yeah, this narrows the scope of what I need to learn a lot and makes that learning process more manageable. Because if it doesn't contribute to getting that application to work, I don't pay attention to it.
Okay.
By the same token, I know that there are big holes in my background. There are lots of things that I don't know about computer science. I mean, even after all these years, I still feel like it's a big, wide world that I can learn in. Fortunately, I think one of the strengths of my career is that I've been able to continuously learn pretty well. I'm the model lifetime learner. It's still driven by the scope of what I need to know, but I'm a lifetime learner, and that helps me find the things I know. And, of course, Google is a tremendous resource.
Right.
But before Google, I bought, as I think a lot of self-taught programmers do, I bought a lot of books, of which I used probably a quarter.
Right. Yeah, I'm in the same mode over the last, 10 years. Not only the number of books, but video courses.
Yep.
And other things like that. And it's literally how I fell into Real Python, is continuing wanting to learn and finding these great resources. Yeah. And, so many of them, I keep buying these humble bundle things.
Yeah.
Just because it's like, well, okay, $15, $20 or what have you. I know I'm going to use some of it. At least it's a smaller bookshelf. I can carry it around.
Right. Yeah.
it's kept in the cloud. So
yeah, that's a very handy thing to have. I've done that as well.
So how do you keep your skills? I know you said that you're a lifetime learner, and in the past you've bought lots of books. Are there other techniques that you use to keep honing your skills?
I try things a lot when I get interested in something, and I tell my students, I teach at a couple places, and I tell my students and the people who I mentor, pick a project that you're interested in, and that will not only narrow the scope of what you need to know, but it'll keep your interest up in actually doing it. My career has spanned a lot of different jobs and industries, and part of that is driven just by boredom. I want to learn something new, and this job is not giving me the opportunity to do that. I'll take another job in order to make make 8 hours of my day learning that thing.
Right.
Fortunately for me, I've been very successful, not always, but I've been very successful picking areas of interest that provided me with a career, a job. Like getting into the web. I was not in the .com boom, but soon after it, and that provided me, a place to learn stuff for a long time. I got into Python probably a little earlier than the actual uptick in Python's, rapid growth lately. But it was a fortunate pick that, Python is eating the world, and I've been doing it for a long time, and that's a good space to be. But all of those choices were driven by personal interest, by building projects. I built my own website for my personal site. I built, this Polargraph thing, which was a lot of fun. And then just little tools all the time, like, the automate the boring stuff with Python. I do that a lot.
Yeah. So how did you get into writing articles?
Well, to tell you the truth, I don't really know. I can't remember if Dan got in touch with me or I got in touch with him, but I had been doing presentations we have Engineering All Hands where we all get together. And because a lot of us are spread all over the place, ShutterFly's all over the country.
Okay.
And we get together to meet and, build relationships, and which is really valuable. But during those get-togethers, they talk about what the business needs, but we also have a chance to give presentations to each other about interesting things. I'm a fairly good public speaker. I was asked a couple times to give presentations, and then I was asked every time we had an all hands to give a presentation. And so I put together some of these presentations that were well received within the company. I can't remember how I got hooked up with Dan, but I initially wrote for debater.org, his personal site, his blog.
Yeah.
I took some of those presentations that I had put together and turned those into articles, and they were well received. And then when he acquired realpython.com, we kept going. And I enjoy teaching. I enjoy the sort of the mentor aspect of writing articles. It's certainly strengthened my writing ability. I think I have a pretty good way of expressing complex concepts in understandable language, in an enjoyable read. And so that's sort of how I get into it. I think I have 5 articles currently and another one that should be coming out fairly soon.
Oh, cool. You have a large series, large being 4 parts,
yeah.
about APIs and using Python to develop REST APIs. What I was wondering about is, why did you choose to write about that?
And that came directly out of a presentation I gave at one of the all hands meetings. In reading about REST APIs, a lot of the stuff that I read about REST and arguments that I saw about REST, I was very like, this is sort of weird. This is it's making it a lot harder than it really is, or it should be. Plus, people were at work where I saw some APIs that people were promoting as REST, and I was looking at them like, no, these are not.
Huh.
They're really just remote procedure calls. They're not REST at all. And so I took an interest, and I thought that the whole idea about REST was really useful for building a web application, where in REST you kind of think about objects as things. If you're thinking about an e-commerce site, have an order, which is a thing, you have a customer, which is a thing, and then they have relationships to each other with like addresses and how much I've bought and products and things like that.
Okay.
But all those things are unique things. And in REST, you sort of think about things like that as in terms of nouns. I have a person, I have an order, I have a product. And a lot of that fits on a lot of different, not necessarily e-commerce, but a lot of things like that. And in REST, that idea of okay, my URL to a REST item is a unique path to a group of things, a collection of things, or a particular thing. And then the HTTP methods, get, post, put, and delete, really let you express almost everything you need to do with one of those things. I need to create one. I need to get one. I need to get a list of them. I need to delete one.
Right.
Those are all very handy. The HTTP methods provide the verbs for what you're going to do to them, and the URL provides the noun or the plural of nouns of the things that you want to get. And that was a nice concept, and that really appealed to me, and I thought I could write an article. It's based on my own opinion. It's very opinionated set of conventions. REST is not a protocol. It's a convention, I think. But I thought, this could clarify how people could think about this convention and use it to their advantage.
I have a lot of background in database work in Microsoft, doing SQL. And so it kind of goes back to the concept of CRUD, which stands for create, read, update, and delete, all those standard things that you would do to a database. So what are the ways that other people were trying to explain it that to you didn't make sense?
Well, and sometimes they would have a URL where they would have an end thing that was a verb. It was an action. It's not it's not a noun. They're like, okay, modify picture. And then the rest of the parameters, the path parameters were actually parameters to the function. So they'd have like slash enlarge slash size equals blah, blah, blah slash. I'm like, this is a function call. This is not REST. This does not describe a unique thing that you could get every time. That's unique forever. And so to me, it was like, this is a function call. This should be called another way and not be called REST. It's just a remote procedure call. Plus, I really felt strongly that trying to embed function parameters on the URL path was not a good idea, that you'd be much better served by using post or put and passing a JSON payload where you could really, you could put anything in there as the parameters to your function. If you have the parameters in the URL, it's kind of difficult the parameters have to be in a certain order. There aren't any that are defaults. There's difficulties in using them, I think.
Let me unwrap that a little bit. You're saying, as far as making those modifications to a particular endpoint, you're sending like a payload as opposed to individual pieces of data, like you're sending it as a set of JSON?
Yeah, in the case where I'm thinking where something is a procedure call, a remote procedure call, the endpoint is the function name.
Okay.
But you end right there. There's maybe there's a query string, maybe not, but the rest of the parameters are either in the query string or in a JSON payload. I find the JSON payload using input and post much more adaptable than trying to squeeze everything into the URL.
Okay.
You can have structured data. The data has types, things like that.
So like, let's use a photograph as an example. A person could have a set of parameters that they want to change about that.
Yeah.
Okay. So like they want to, modify the size, they want to change the brightness, they want to do whatever. So those pieces of information are what are packaged then. And
well, you could do all of those stuff, but let's if you think about something like if we were trying to create a web interface to something like ImageMagick.
Okay.
The Linux ImageMagick tool. Well, ImageMagick has a ton of parameters, a lot of them.
Okay.
So trying to encode those in either the path or the query string, it'd be possible, but it'd be kind of awkward, I think. Whereas encoding them into a JSON structure, which can be hierarchical, has names and value types, data types, integers, strings, collections, arrays and objects. I think that's a much more powerful interface to a function than trying to make everything URL safe, for instance.
Okay. When you went in to do this collection of articles, which now, like I said, was like there's a set of 4 of them.
Mm-hmm.
Why did you pick the particular tools that you used there?
Well, I picked stuff that I knew I was familiar with, like Python, of course, and then I used Flask because that's the web server I use predominantly. I like its simplicity. I like that you can add to it what you need. It doesn't come with everything.
Okay.
These days, the stuff that I write, because I'm sort of a full stack developer, I write web servers that don't really provide any HTML or CSS. All they provide are APIs.
Okay.
To provide data. And the front end code is written in Angular or React or Vue or something like that, and just calls those APIs to populate user displays. So Flask was a nice tool for that. It's very simple, straightforward. I thought it was scalable. It has very good performance. If you're not dealing with Google-sized problems, it has very, very nice performance. And then I used this tool called Connexion, which is a way to implement the Open API, or what's also called Swagger.
Okay.
Which provides a lot of nice way of thinking about how to provide REST to an interface, the way you provide REST. And the thing I liked about Connexion, there's a lot of tools, and there's quite a few tools for Flask that let you do REST interfaces and provide the Swagger UI that comes with it. Some of them are embedding information in the doc string. None of that really appealed to me. It kind of added a lot of overhead to my source code, which I didn't like. Whereas Connexion uses a configuration file, either a YAML or JSON configuration file, and is separate from your code. Your code reads that, of course, and then it connects an actual endpoint in code to an endpoint on the API. But after that, everything else is configured in the connection file. And the thing I liked about it is that it's a way of defining what your API endpoints are going to look like prior to actually building them.
Okay.
If you ever built a API, a REST API, or any other kind of HTTP interface on a web server, probably the actual endpoint code can be spread out pretty far. There's a lot of code in between that, or it could be in different modules. So it's not necessarily right on top of each other. That makes it a little harder a little more cognitive load on your brain to think about all of those APIs in one space and to keep that all in the domain of your brain.
Yeah.
Whereas Connexion, it's literally just, here's the API, here's its definition. Next, here's the next API endpoint, here's its definition. For me, that made a lot of sense about how to think about the API. Like when I'm building something, I often don't have a really clear spec or idea of what the API is going to look like. So I'm building it as I go. I'm iteratively building it. Well, being able to see it in that Connexion configuration file, I thought was very helpful to my being able to sort of see what it's going to look like before implementing in code.
It's very much a list of specifications then.
Oh, absolutely, yeah. And it has so many nice features for validating the input, different ways of supplying. You can specify. You can get pretty crazy and specify. This is exactly what I'm expecting as a string. This is the list of things that I will expect. Everything else is going to throw an error. You can define the responses that you expect. You can define the errors that you can raise. But it's very powerful that way as well. And it does a lot of validation of both incoming and outgoing requests and response for an API. It's pretty sweet that way.
Cool.
And then I also use SQLAlchemy to interface with the database because I like dealing with objects rather than raw data. So that lets me deal in Python objects, which is the response for an API. And then because an object is not directly serializable for a REST API, I used another tool called Marshmallow, which is a serialization library, which is very useful. It smoothly turns SQLAlchemy objects into plain Python objects that can be serialized as part of a REST API.
And that's a big part of sending that information over the web.
Yeah.
Using an API is this idea of serialization. What does that mean?
Well, it mostly like a datetime object in Python. You can't just say in Flash, you can't just return a datetime object. Even with, through when you say JSONify, it's like, what is that? I have no idea what that is. And it blows up.
Okay.
So what thing like Marshmallow does is it converts that to a string. And most of the time I'm working with this stuff, it turns it into a UTC timestamp string. So that now it's just a string. Well, JSON can handle that.
Okay.
Complex data, dictionaries, or even objects like SQLAlchemy always gives you back a Python object with attributes. Well, you can't just serialize a Python object because there's other stuff attached to the object besides the attributes you're interested in. So Marshmallow lets you say, okay, this attribute is this type, this attribute is this type, this attribute is that type, or I have a special type I have like a complex number, for instance. If you want to send that back as an API response, well, you might need to code a little piece, a little function in there to say, okay, in my convention, I'm going to represent a complex number like this in the JSON, and it will do that for you.
Cool.
And once you have it set up, it's kind of like setting up schemas for a database. You're setting up a schema for serialization, and once you have those connected, it's actually pretty smooth. You just plug the output of SQLAlchemy into one of these Marshmallow serializers, and then send the results out through Flask, and you're done.
Nice. Across the series, what database types are you using?
Oh, I was using, I think I was talking about it like a miniature blog post thing. That's sort of a silly blog that you can make comments on. So there would be, a list of comments or a single comment. The comments could have, the blog posts and a list of blog posts, and those blog posts could have comments on them.
Okay.
As a related thing. That was the very simple database that I was using. Because initially, the first article was strictly, the thrust of the article was presenting the REST interface. And so I used a simple in-memory structure, just a dictionary in memory as the data source for the blogging application. And then I was using Connexion to show how to present that as an API, using that very simple in-memory data structure. And then as the article went on, then I slowly turned that into a database, and then I started using SQLAlchemy and Marshmallow to show how you could persist that in-memory, that blogging structure to a database. Because one of the comments, obviously, that I got for the very first article is like, oh, every time I start the example, all of my new data is gone. I'm like, yes, well, it's in memory. There's no persistence.
All right.
So then that was the next thing, was like, how do I tie a REST API to persistent data that I could change and modify and would persist between machine startups? And then the last article was, Dan and I had a conversation about it, because the last article, it presents nothing new about Python. It's the exact same Python as in the third article.
Okay. But
the last article was presenting a much more full-featured JavaScript-driven web application using raw JavaScript, no libraries at all, no jQuery, no Angular, no nothing like that. And that was the thrust of the article, was presenting, okay, I have an API. How can I consume it? How do I consume it in a meaningful way?
Okay. When you say consume it, that's not necessarily for you. You're setting it up for your users then, in some ways, right?
Yeah, the web application was strictly a demonstration about how you could consume that API. How do you use Ajax to make calls to that API in order to get data and populate a web application? Although anything that can do HTTP calls could access the API, but I use the web application because that's a very common use case.
Right. Cool. You're in the process of writing a book right now.
Yeah.
What's going on there?
Well, I think the same. It's sort of like I fell into it. One of the acquisitions editors at Manning's Publishing, who's a pretty big publisher for tech books, got in touch with me and had read some of my articles on Real Python, and I guess thought that I conveyed some things fairly well. And we got to talking about if I'd be interested in writing a book and what that book might be about and what my interests were in the topic. And we eventually came up with a proposal for a book that they said, yeah, let's go. So I'm writing that book. And for me, the point of the book, again, it's exactly what I've been doing. It's just teaching and doing a little mentoring and trying to be helpful to people.
Okay.
There's a lot of books about getting started with Python, like Python for Dummies and Learn Python in 24 hours. Those things those have a place, I guess. But that's not the kind of book I want to write. I don't want to write a beginner's book. And I don't want to write an expert's book, like a reference book about, this is how you do network programming, or this is how you do advanced hacking.
Okay.
Or even the cookbooks. I find the Python cookbooks are really useful. I use them a lot. And their purpose is to present a bunch of very focused solutions to very particular problems. And those are great. But for me, I'm a fairly experienced programmer. So those are great for me because I can make the jump like, oh, this problem doesn't solve exactly what I'm trying to do, but I have enough experience to extrapolate from it and adapt it to my needs.
Okay.
So my goal for the book is to present sort of the middle ground. I want to help people who are already Python programmers. They know Python, they know how to make loops, they know how to do conditionals. They've probably written, single file Python programs. They might have automated some interesting stuff for themselves, but are looking to move further down the road towards being a developer, thinking like a developer, not just being a programmer, but thinking like a developer, and take on larger problems and use the tools they have and the tools that I hope that they learn from the book to put those tools together in a way that creates something elegant and beautiful and much more complex than they can do now. It's like being able to use a hammer and a screwdriver and a saw. I can do those things, but I'm not a skilled craftsman.
Right.
I can't put together, an armoire or a nice table. So I'm trying to help people do the same thing in Python. They have a nice tool set. How do I use those tools to accomplish more interesting, complex, and satisfying projects?
Cool. So what's the title?
The title's called The Well-Grounded Python Developer. And right now it's available on Manning's early access program. I think our go live, well, it's gone live now, but the actual publication date is probably going to be 2021, given how long it's going to be.
Okay. So out of all the chapters and things that you're writing about, what's the topic that you're most excited about?
I think just seeing how simple building blocks can come together. One of the things that's driven my career, at least the way I think about my actual work, is this idea of, I like object-oriented. I'm still a very much object-oriented guy.
Okay.
And I like the idea of things. I'm going to create things, And there are collections of things. I mean, I would say 80% of the problems that I've solved with programming have to do with, okay, here's the thing, and then dealing with a collection of those things and the relationship between those two, and maybe another collection, or, that goes to several deep. You have things, a collection, another thing that contains that collection, another collection, on like that, like a hierarchy.
Sure.
But those kinds of problems and how you can use tools in Python to solve them. Like in the book, my plan is to use, I'm building a more sophisticated blogging application using Flask, SQLAlchemy, Marshmallow, presenting a REST interface. And that's, the goal is not, being able to build that application. That's nice that you get that at the end, but that's not the goal of the book. And you can get a blogging application off of the shelf. No one needs to write another one.
Right.
My goal is that the journey to doing so, about how you see these are objects, how to create good objects. How do you create a good API? Why did I learn objects? Well, I wanted to be able to use SQLAlchemy. Why did I learn a good API? Because I want to think about REST. I've got an idea about how to do that. How do I persist it? Well, I can use SQLAlchemy, which I've learned now, to aid my journey down persisting data. I want to make very clear that using something like that, using something like SQLAlchemy kind of abstracts away the data representation in the database. Not entirely, but it goes a long way. So you could think about like, oh, well, in the real world, I might start with a MySQL database, and then as things get really heated or big, or my company grows or something, there's no reason in the world they should suddenly say, oh, we're going to use Postgres or Oracle now. Well, with an abstraction like SQLAlchemy in between your code and the database representation, that's not such a big deal. I can make that jump pretty simply.
Right. And
then the idea of APIs, I think, are a little abstract for people. Like, what the heck? I hear this term all the time, API. What does this really mean? And what is a good one? What does a good one mean? How do I design a good API? And I'm hopeful that, I present like building an API using object-oriented methods to build an API. Why namespaces are wonderful in Python, and we should use them as much as possible. All those things are building towards becoming stepping stones to bigger concepts like a REST API. How does that tie into the database? How does that tie into the front-end consumer of that API?
Something I was thinking about as we were talking is, how do you think that all your experience working with physical hardware devices has helped you become a better programmer?
Well, I'm sort of in a sweet spot right now. Like, I really like the embedded world. It's a lot of fun. That sort of rubber meets the road, speed at all costs kind of thing really appeals to me. That's not where I'm doing now, and I'm glad not to do it because it's very demanding.
Okay.
But the work that I do now has enough of an interface to the real world that really appeals to me. Working in production where I'm actually setting things up for a machine to actually do something with it, and then reacting to users' activity like scanning barcodes. That's a pretty sweet spot for me about control. Not having to actually run the motor myself, but interacting with a physical device. But those things, working with embedded systems, one of the things I learned was that the most direct approach is not always the best approach. Like in embedded systems, you're often very constrained by memory, how much CPU you actually have, how much time you have to actually do something.
Okay.
So there are a lot of shortcuts you take in order to achieve a very specific goal. The advantage in an embedded system is that usually once you reach that goal, the requirements of that goal change kind of very slowly. So you don't have to rethink, you don't have to throw out everything and start over. Those shortcuts that you might have taken to achieve the goal, like, okay, I'm using this weird data structure here, but it works in this case. I'm using a linked list rather than, I don't know, a hash table or something like that. It works well enough for the use case. A lot of those things, I knew they were shortcuts, and I knew the choices that I was making, constantly weighing the advantages, disadvantages of those kind of things. But it made me very aware that scalability matters. So in my work now, we often say this to each other: shipping is a feature, and Python lets us do that quickly. Shipping is a feature. It also doesn't limit us to shortcuts. We can do some really elegant, scalable infrastructure and techniques and ideas and implementations without sacrificing being able to deliver. And a lot of, what I do, almost everything I've done outside of embedded systems has to do with scale and robustness. And like we talked about before, the fourth quarter at my job is very busy, and those systems have to continue to perform, and they have to kind of perform in a deterministic way at a certain pace. And that kind of thing changes your thinking. Well, for me, it helps me to think about the tiny systems I did build and the bigger systems I'm building now. Having known the shortcuts and the quick and dirty stuff that I did in the embedded systems makes me think bigger picture now.
Yeah. So I have a couple questions that I'm doing as sort of a weekly thing.
Sure.
The first one is, what's something that you thought you knew about Python, but it turned out that you were wrong about it?
It's not I have one that I thought about when you say this. It's not a particular thing.
Okay.
But whenever I've been in a position where I've wanted to optimize something in Python,
okay,
if I try to do it by the seat of my pants, like, oh, I know what's going on here, I have been consistently wrong every time. And it's not until I actually profile something and discover, where the bottleneck is, and then think about where that is and why that is, that I realize, oh, okay, now this is something. But my intuition about optimization is almost always wrong about Python.
What's a good tool that you use to do the profiling work?
I use the C profiler and the stats modules in order to just spit stuff out to see time spent in function calls. The other one is the number of function calls. Like if I feel like there's a hotspot somewhere, being able to turn on the profile on or off around a set of functions and then see, something gets called 500,000 times. You're like, what is going on there?
Yeah.
It also helps me think about the big picture stuff in terms of, Python. C is kind of, back in the day, C was famous for like micro optimizations, using this instruction versus that instruction. I don't really play that game too much anymore. I want to think about, I don't want to get an incremental gain in performance. I want to get an order of magnitude gain in performance. So usually that leads towards thinking about different data structures, a different approach, a different algorithm to how I'm doing things, but to really look at a system-wide rather than, if I use a dictionary here over versus a list, I could save a microsecond every hour.
Right. So it sounds like you might have a newer answer then too.
Oh, yeah. There's things about Python that surprise me. I've been slowly getting up to speed on data science.
Okay.
Big data.
Yeah.
I'm not much of a database guy. I'm not a particularly strong DBA or anything like that. I know how to get around and create databases and stuff like that, but I'm not a great database guy. And I've been thinking about big data. And so some of the things that is holding me back, like I'm looking at pandas and NumPy and some of those things. Some of my assumptions based on my database experience are holding me back, are surprising me about pandas, like how pandas works and how NumPy works and how those things work is very different than dealing with a database.
How so? What are some of the differences you can spot?
Well, just relying on the tool more and the way the tool works to query data, to normalize data. One of the things that I haven't dealt with very much is normally when data goes into the databases that I've worked on, it comes through a system, usually that either myself or someone else like me built. And in pandas, where people are analyzing sort of raw data, CSV files and things like that, where
sure,
data can have all kinds of weird behavior, like it's supposed to be a number and it's really a string, or it's in the wrong field, or it's blank.
Yeah.
And then the whole idea of trying to get the data to be meaningful, either doing analysis of it, statistical analysis of the data itself to fill in the blanks or throw out outliers or decide what's good data or bad. This is a whole new thing for me that I'm discovering.
That was my last gig working at a bank. I landed in the marketing department. So my data was coming from, 5 different systems in the bank, everything from, okay, there's this information about customers that are in the credit card system. And then there's this information from mortgages. And then there's this information from here. And so then sort of lumping it all together, and everything's been stored and in their own weird optimizations. And so it was like,
yes, right.
So much of it was just grooming of that data and making it
it's unbelievable,
tidy and useful. Yeah. That was the biggest part of my job.
Last year, I volunteered and took part in a data fest for Vassar College. I just acted. I was there for a couple hours acting as a kind of a consultant to help the people involved with either programming or some just questions about what it was, just being available as a software developer. What kind of life was that?
Yeah.
The data that they were given as part of this little 2-day exercise was like frightening to me. It was horrifying. It was like, what is this pile of junk that they're trying to analyze? But they were taking it in stride because they were used to that kind of a thing. And it was a real eye opener for me.
Yeah. It's a huge part of it. And it's not necessarily the fun part of it either, too, in some ways. So
no, but apparently, it's a necessary part of doing that kind of work.
Yeah, absolutely. The next question was, in the whole wide world of Python, events, packages, editors, hardware, what's something that you're excited about right now?
I think the big data stuff, I think, is really going to become important, and AI. That really interests me.
Okay.
This is my own personal take on things. I in terms of my altruism about things, I tend to think locally, not globally. So I like to get feedback on the things that I'm trying to improve. So, I teach at this little STEM school near me because I like to interact with the kids and see if I can teach them a little bit about Python. By the same token, this whole AI thing is really interesting to me, but I like to think I'm thinking a little bit smarter. Like the whole idea of these self-driving cars is incredible,
right,
and amazing. Things like that. But the scope of that or the scale of that is beyond what I want to get involved in. And so I'm thinking, like, there's things that I would like to think about in terms of AI on a smaller scale. Like, at work, I'm thinking, how could I use the data that we have at work to optimize the production flow, like to do staffing predictions, or when do we need to think ahead about capacity improvements, or just simple things like bus routes, for instance, simple things like bus routes. How could you improve municipal bus routes with AI?
Yeah.
Like the planning of the scheduling and their routes or where they might go, when they might be there. Could you use AI and big data to improve that? Just simple things like that.
No, I think that is pretty awesome. I'm sure you got a huge data set there at ShutterFly of things that you could look at. Okay, how does our schedule ramp up, and what kind of things do we need to be prepared for? If we introduce something new, what's the typical expectation, and being able to staff for it. And that's very cool.
Yeah, I mean, there's a lot. Certainly, there's the obvious stuff, and I know they're looking at is at any company that's involved in the internet is thinking about marketing, how to use this data for marketing. Where are the hot spots for when I should apply, I don't know, discounts? Where are my customers? Who are my customers? How do I appeal to them more? That's all very important, certainly. But my area is not that. I'm in production, and I want to think about how can I improve production so that it's, like, again, how do I make it more robust, more scalable? How do I help the people I work with who are on the production floor? How do I help them do their jobs better and live better lives? Can I use information and intelligence that I can data mine from what we know to make that kind of stuff happen?
Cool. Yeah, that's awesome. So if people were interested in reaching out to you, do you have a particular way that you want them to reach?
I guess probably the easiest thing is to find me on Real Python.
Okay.
And you just search for my last name, and you'll turn up my articles, and you can contact me that way. You can also find me on LinkedIn.
Okay.
I'm always putting stuff on LinkedIn. I find that it's become a very powerful platform.
Yeah.
I post my stuff that I write and the various things that I'm doing as part of my profile and just on posts.
Cool. Well, thanks again for talking to me.
Well, thank you, Chris. I really enjoyed it.
I want to thank Doug Farrell for being my guest this week. And I want to thank you for listening to the Real Python podcast. Make sure you subscribe to the podcast in your favorite player. And if you like the show, leave us a 5-star rating and a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and I look forward to talking to you soon.